Hey all, today we are looking at the periodic table. So this is basically a way to organize chemistry. So why do we do it? Well, the periodic table is kind of neat because it's a way to organize the elements in a useful way. Because the elements are basically everything that everything is made of, it uses the properties of the elements to arrange them. So initially it was done by atomic number. It was done by a guy named Yuri Mendeleev, and the cool thing is he ordered them by properties, and he didn't actually know what atoms were, or he just knew what the elements were that couldn't be broken down. So he ordered them by properties, and the cool thing was, when we actually figured out things about the atom, we discovered that his order actually made a lot of sense. So the first thing is it's ordered by the atomic number. So we start off by ordering from smallest to biggest. So they're ordered by the atomic number, which is the number ended up being the number of protons in them. So the first atom was hydrogen, that was 1, then helium, then lithium, beryllium, boron, nitrogen, and carbon, it just kept going. But they were all exactly, except for one. He only made one mistake. They were all actually, he had put them in order by the number of protons, which is really cool because he did this before we knew what a proton was. So the first thing is they're ordered by numbers. So the smallest atom to the biggest. The next thing we noticed was that the order he had put them, the things with similar properties, once we discovered the electron, it actually turned out that all the things with similar properties had one thing in common. Their electrons, they had the same number of electrons in their outer shell. So everything in this first row, hydrogen, lithium, sodium, they all had one electron. Beryllium, magnesium, they behaved the same. They all had 2 electrons. All of these ones didn't react at all, and we discovered they all actually have a full outer shell of electrons. By the way, we call that valence. The outer shell is called the valence shell because that's a really special. It doesn't matter how many electrons are in the inner shells. It actually, for chemistry, it just matters outer shell. That's all you care about because that determines all the properties of the atom. So carbon has 2 shells and 4 electrons in its outer shell, which is you're going to discover as we go through chemistry is really, really important. It's why we're made mostly of carbon. So all carbon, silicon, they all have 4 in the outer shell. Silicon just has 1 more shell. And it turned out that was what determined the properties. So for example, all the metals were in the same place. All the nonmetals have the same properties. These are the noble gases. They don't react at all because their electrons are full. These are called metalloids, which are kind of metal, kind of not. Really useful to us now because remember, metals conduct, nonmetals don't. Metalloids can conduct, but we can basically do what's called doping them. If we add metal to them, it makes them conduct a little better. If we add non-metal, it makes them conduct a little worse. So this is what all the solid state electronics is based on. So all your things in your phone and stuff like that, we actually can't have conductors, we can't have insulators, but we can have very specialized things that are sort of in the middle of both. And these are actually really, really important to us right now in electronics. So here's the way you can tell. By looking at the periodic table, you can tell what something probably is. With the exception of hydrogen, which is kind of special, everything on the left, it's a metal. If I give you an atom and you notice that it's here on the periodic table, it's a metal. If it's in this little thing here, it's a non-metal. So basically, from 14, 15, 16, 17, on this angle, these are the only things that aren't metals. Everything else in the periodic table is actually a metal. So, here are the orders. Here are the groups you need to know. The most metal of metals are what are called the alkali metals. They are metals that are extremely reactive with nonmetals, and we're going to learn about why a little later in grade 10. They're extremely reactive metals, so things like lithium, sodium, potassium, stuff that you throw in water and they explode. Very reactive metals. That's the first row, row 1. Row 2 is called the alkaline earth metals. I don't really like these names, but I didn't name them because they kind of sound the same. These are alkali, these are alkaline. They're somewhat reactive. So things like magnesium, which will burn, but you have to actually give it some energy to make it go. Normally, you could just hold it in your hand, it's fine. It won't react. It'll just oxidize very, very slowly. They are somewhat reactive. So alkali, very reactive. Alkaline, they're somewhat reactive metals. Halogens, way over to this side. These are the most non-metal of the non-metals. The halogens only have they're missing one electron to have a full outer shell, which by the way is what every atom wants to have. You want to have a totally full or totally empty outer shell. These are so close to being full, they will grab an electron from anything to be full, makes them incredibly reactive. They're very dangerous. In fact, fluorine is the most reactive of them. It's the most reactive element there is. You actually can't keep fluorine in a jar because it will eat the glass of the jar. It will react with absolutely anything. Fluorine, to store fluorine, you actually have to keep it already reacted with something else. So they're incredibly dangerous and very, very reactive. So things like fluorine, chlorine, stuff like that, really, really reactive. The last one are the most non-reactive, the noble gases. They have a full outer shell, so they're stable. Because remember, every atom I said wants to get a full outer shell. Because they're already full, you can't make a noble gas react in a chemical reaction. So things like helium, neon, argon, xenon. This is why, by the way, you can inhale helium from a balloon and it's fine. Just make sure you're stopping to get some oxygen as well, because you can't breathe helium. And it won't do anything to you because it literally can't react with anything in your body. They don't react. It's also why we use them in neon lights, stuff like that, because passing electric current through them, again, they don't react. They won't lose an electron, they won't gain an electron. So they're a good gas to put stuff like that in. So noble gas, not reactive. So that's basically what you need to know of the periodic table. We're not worrying too much about the transition elements. They'll be grade 10. Lanthanides and aldehydes, they'll be grade 11. For you guys, what I really need you to know, metals are on the left, non-metals are on the right, and I need you to know these 4. Alkali, alkaline, halogen, and noble gas. So reactive metal, somewhat reactive metal, very reactive non-metal, not reactive gas. That's basically what I'd like you to know from the periodic table and why it's actually structured the way it is, that it goes by the number of protons and then it goes by how many electrons you have in your outer shell. And that's really all you need to know, basically. If you understand how the periodic table works, you understand just about everything about why atoms have the properties they will, why they react the way they do. It's probably the best cheat sheet you're ever going to get in science. All right? So the project for this is doing some exploration of the periodic table to learn what you can find from it. Good luck. See you next time.